Space is vast, incredibly vast. It's almost beyond comprehension, with billions of galaxies, each home to billions of stars. Our solar system, a mere speck in this immense cosmic expanse, is filled with a stunning variety of celestial bodies. Among these are asteroids, rocky fragments left over from the early days of our solar system's formation. Most of these asteroids drift harmlessly between Mars and Jupiter, forming what we call the asteroid belt. However, some asteroids, known as near-Earth objects, NEOs, have paths that bring them close to, and sometimes intersect with, Earth's orbit. These wandering celestial bodies, while fascinating to study, also present a potential danger to our planet. Discovered in 2004, 90942, Apophis is a notable near-Earth object, NEO. Named after the ancient Egyptian deity of chaos and darkness, Apophis quickly captured the interest of both scientists and the general public. Early calculations of its trajectory indicated a concerningly high chance of an Earth collision in 2029. Although subsequent analyses have significantly reduced this probability, the initial alarm highlighted the genuine threat posed by NEOs like Apophis. Apophis stands out due to its size, which is estimated to be over 1,000 feet in diameter, classifying it as a potentially hazardous object. An impact from an asteroid of this magnitude could result in catastrophic effects on a regional or even global scale. The discovery of Apophis underscored our cosmic vulnerability, emphasizing the necessity of ongoing observation and research in planetary defense. Grasping the characteristics, orbits, and potential dangers of NEOs like Apophis is vital for protecting our planet. Worldwide, astronomers are diligently monitoring Apophis, refining its trajectory and evaluating the risks it may present. Their efforts yield critical data that shapes mitigation strategies, ensuring we are better equipped to handle potential space threats. This proactive stance on planetary defense is crucial for our long-term survival. By examining Apophis and other NEOs, we deepen our understanding of the universe and our place within it, while also developing the expertise and tools to shield our planet from cosmic dangers. On a serene, starry night, astronomers made a startling discovery. They spotted an unusual object moving rapidly across the sky. This object was later identified as 99942 Apophis, an asteroid with a potential to impact Earth. When 99942 Apophis was first discovered, initial calculations suggested a significant chance of impact with Earth in 2029. This caused a global stir among scientists and the general public alike. Media outlets around the world picked up the story, leading to widespread concern and speculation about the potential consequences. Experts quickly began to refine their calculations, using more precise data to better understand the asteroid's trajectory. These efforts were crucial in determining the actual risk posed by Apophis and in planning potential mitigation strategies. In 2029, Earth will experience a cosmic close shave with the asteroid 9942 Apophis. This near-miss event will see Apophis coming within 19,000 miles of our planet, closer than some of our satellites. Astronomers around the world are preparing to study this rare event, which offers a unique opportunity to learn more about near-Earth objects. As we look ahead, the potential threats posed by 99942 Apophis continue to be a topic of concern for scientists and researchers. While current predictions suggest a low probability of impact, the uncertainty surrounding its future trajectory keeps the scientific community vigilant. Continuous monitoring and advancements in technology are crucial to ensure we stay prepared for any changes in its path. The collaboration between international space agencies plays a vital role in our collective efforts to mitigate potential risks. By staying informed and proactive, we can better safeguard our planet from the uncertainties that lie ahead. Picture a skyscraper, not standing tall in a city, but drifting through the boundless void of space. This is Apophis, a massive asteroid, measuring approximately 1,100 feet across. To give you a sense of scale, imagine the Eiffel Tower soaring into the sky. Apophis surpasses it in height. Envision this gigantic rock, cloaked in the darkness of space, speeding through our cosmic vicinity. Studies indicate that Apophis is not a perfect sphere. Instead, it has a slightly elongated peanut shape, a common trait among asteroids. Its surface, likely covered in craters and dust, reveals its ancient past, a record of billions of years of cosmic impacts and gravitational forces. Apophis, like all celestial bodies, is governed by the laws of gravity, locked in a complex dance around the Sun. Its orbit, elliptical in shape, takes it on a path that extends beyond Earth's orbit, swinging closer to the Sun than Venus before looping back out towards the asteroid belt. This cosmic choreography, however, is not a solo act. The gravitational pull of planets, especially Earth and Jupiter, can subtly alter Apophis's trajectory, causing slight shifts in its path over time. These seemingly minor nudges, accumulated over centuries, can have a significant impact on Apophis's future encounters with Earth, making precise long-term predictions a complex and challenging endeavor. While telescopes provide essential data on Apophis's brightness and trajectory, radar technology delves deeper into this cosmic traveler. By sending radio waves to Apophis and studying the returning signals, scientists can generate high-resolution radar images, showcasing its structure, rotation, and surface details with exceptional clarity. These radar images have been pivotal in verifying Apophis's elongated form and have even shed light on its spin rate and rotational axis. This comprehensive understanding of Apophis's physical properties is vital for refining its orbital path and evaluating potential hazards. The more we comprehend its dimensions, form, and rotational dynamics, the better prepared we are to forecast its future movements and devise strategies for any close encounters. Section 4. Echoes from the Past. Composition clues. The light reflected from Apophis's surface reveals secrets about its makeup and history. By examining the spectrum of this reflected light, scientists can uncover details about the minerals that constitute this space rock. These spectral signatures indicate that Apophis is an S-type asteroid, primarily composed of silicate minerals, akin to many rocky bodies in the inner solar system. This analysis sheds light on the early solar system, providing a window into the materials that existed during its birth. Deciphering the composition of Apophis aids in assembling the grander picture of our cosmic origins, linking this asteroid to the broader story of our solar system's development. Section 5. The Ever-Changing Path. In the realm of celestial mechanics, nothing remains the same. The orbits of asteroids, though they may appear stable, are in a state of constant flux, influenced by the gravitational pull of planets and other celestial bodies. Apophis is no exception. With each new observation, our understanding of its orbit evolves. Astronomers employ advanced computer models to simulate the intricate dance of gravitational forces, continually updating Apophis's trajectory and predicting its future path with greater precision. This ongoing monitoring and refinement are essential for maintaining the most accurate information about Apophis's potential threat. Although current projections indicate a safe passage for the near future, the ever-changing nature of its orbit highlights the necessity of ongoing vigilance and continuous research. Section 1. Cosmic What-ifs. Space, with all its tranquil allure, harbors the potential for devastating occurrences. Although the immensity of the cosmos makes a direct collision between Earth and an asteroid a rare event, the mere possibility serves as a stark reminder of our cosmic fragility. When considering asteroids like Apophis, comprehending the potential impact consequences is not about yielding to fear, but about fostering responsible preparedness. By delving into these hypothetical scenarios, scientists can better evaluate the risks and devise strategies to mitigate potential threats. It's about posing the tough questions. What would transpire if Apophis, or another asteroid of similar magnitude, were to strike Earth? Which locations would suffer the most devastating impacts? And how can we, as residents of this planet, picture the energy unleashed by thousands of atomic bombs going off at once? This is the kind of force an asteroid like Apophis can deliver. Although not large enough to trigger a global extinction, an Apophis impact would wreak havoc on a regional level. Striking a densely populated area, the immediate devastation would annihilate everything within hundreds of miles. Buildings would collapse, forests would burst into flames, and the shockwave would obliterate everything in its path. For context, the Tunguska event in 1908 flattened over 800 square miles of forest in Siberia, caused by an asteroid or comet fragment. Apophis, though smaller, still has the potential to cause massive destruction and significant loss of life. The vast oceans, covering more than 70% of our planet, pose distinct challenges when it comes to asteroid impacts. Should Apophis collide with an ocean, the repercussions would ripple far beyond the initial impact site. The tremendous energy released would generate massive tsunamis, waves of water that would spread outwards, flooding coastlines thousands of miles away. These enormous waves, potentially reaching hundreds of feet in height, would overwhelm coastal cities and towns, leaving widespread destruction in their path. The 2004 Indian Ocean tsunami, caused by a significant undersea earthquake, highlights the devastating power of such waves. An asteroid impact, however, could unleash even more formidable. Even if Apophis were to miss land entirely, an impact in the ocean would still have global repercussions. The sheer force of the collision would eject billions of tons of water vapor, dust, and debris into the atmosphere, creating a massive plume that could encircle the globe. This atmospheric injection would have far-reaching effects. The dust and aerosols, suspended in the upper atmosphere, could block sunlight, leading to a temporary cooling effect on the planet. Additionally, the disruptions to the atmosphere could interfere with communication systems, disrupting satellites and ground-based networks. The global interconnectedness we rely upon would be severely tested, highlighting even if Apophis were to miss land entirely, an impact in the ocean would still have global repercussions. The sheer force of the collision would eject billions of tons of water vapor, dust, and debris into the atmosphere, creating a massive plume that could encircle the globe. This atmospheric injection would have far-reaching effects. The dust and aerosols, suspended in the upper atmosphere, could block sunlight, leading to a temporary cooling effect on the planet. Additionally, the disruptions to the atmosphere could interfere with communication systems, disrupting satellites and ground-based networks. The global interconnectedness we rely upon would be severely tested, highlighting in the realm of asteroid impacts, probability is a complex and ever-evolving calculation. Astronomers employ advanced algorithms and extensive observational data to gauge the likelihood of an asteroid colliding with Earth. considering factors such as its trajectory, size, and potential gravitational influences. When Apophis was initially identified, the early probability assessments caused alarm, indicating a relatively high chance of impact in 2029. However, as additional observations were made and the asteroid's path was more accurately determined, the likelihood of impact decreased significantly. Present-day estimates indicate that Apophis poses no significant threat to Earth for at least the next 100 years. Nonetheless, it's important to remember that these calculations are continually updated as new information becomes available. Continuous monitoring of Apophis and other near-Earth objects is vital for refining these probabilities and ensuring the most accurate assessment of potential. For centuries, humanity has looked up at the night sky with a sense of wonder, captivated by the vast expanse of the universe and our place within it. However, within this cosmic beauty lies potential danger. Asteroids, the ancient remnants of the solar system's formation, can pose a significant threat to life on our planet. Acknowledging this cosmic risk, scientists and engineers globally have taken on the vital task of protecting Earth from asteroid impacts. This specialized field, known as planetary defense, is a proactive effort to ensure the safety of humanity's future. Moving beyond mere observation, we are now developing the expertise and technology to potentially deflect or disrupt a hazardous asteroid, changing its trajectory and preventing a catastrophic collision with Earth. Picture using a powerful laser to vaporize parts of an asteroid's surface, creating jets of gas that push the asteroid in the opposite direction. This is the concept behind laser ablation, a cutting-edge method for asteroid deflection. Another innovative technique involves deploying a solar sail, which uses the pressure of sunlight to gradually change an asteroid's path. By harnessing the constant stream of solar photons, a solar sail can provide a gentle but continuous push, steering the asteroid away from Earth. A more dramatic approach is the use of a nuclear explosion, not to destroy the asteroid, but to create a shockwave that nudges it off course. This method involves detonating a nuclear device near the asteroid, transferring energy to alter its trajectory without breaking it apart. Each of these techniques offers unique advantages and challenges, providing a diverse toolkit for protecting our planet from potential asteroid threats. The sheer power of nuclear weapons has always been a source of both dread and intrigue. Although their deployment on Earth is a deeply contentious and sensitive matter, some experts propose that nuclear devices could serve as a last-ditch effort in planetary defense. Contrary to the dramatic portrayals in Hollywood, a nuclear explosion for asteroid deflection wouldn't aim to obliterate the asteroid. The strategy involves detonating a nuclear device at a precise distance from the asteroid, creating a shockwave that vaporizes part of its surface. This vaporization would be uneven, producing a jet of material that acts like a rocket engine, nudging the asteroid off its collision course. Despite the controversies and ethical dilemmas surrounding the nuclear option, it remains a potent measure that could be employed in dire situations to avert a catastrophic asteroid impact on Earth. Asteroid threats transcend national boundaries. They present a global challenge necessitating a collective response. Recognizing this, space agencies and scientific bodies worldwide are collaborating to track near-Earth objects, exchange critical data, and formulate unified planetary defense strategies. This international cooperation spans multiple dimensions, from pooling telescope resources for asteroid observation to planning joint missions aimed at testing deflection methods. The United Nations has initiated the International Asteroid Warning Network, IAWN, and the Space Mission Planning Advisory Group, SMPAG, to enhance communication and cooperation among nations regarding asteroid impact threats. This global initiative highlights the consensus that planetary defense is a collective duty, necessitating a unified approach to safeguard our planet from extraterrestrial dangers. In the grand cosmic ballet between Earth and asteroids, readiness is our strongest shield. Although the likelihood of a significant asteroid impact in the near future is minimal, the potential ramifications of such an event are too severe to overlook. Ongoing research and technological progress are vital for enhancing our capacity to detect, monitor, and divert potentially dangerous asteroids. Investing in advanced telescopes, refining deflection strategies, and creating robust international response protocols are critical measures for safeguarding Earth's future. The quest for planetary defense showcases humanity's creativity and cooperative spirit, reflecting our resolve to shield our planet, our home, from the cosmic threats that loom ahead. As we delve deeper into the universe and uncover its secrets, let us also commit to being the protectors of our own world, ready to confront any celestial. On a serene night, away from the city's glow, look up and marvel at the star-filled sky. Each shimmering star is a distant sun, potentially with its own array of planets. In this immense cosmic canvas, Earth is a small, delicate oasis, a pale blue dot floating in the vast expanse. From this vantage point, it's evident that our planet, despite its beauty and complexity, is vulnerable to cosmic forces. Asteroids, like cosmic nomads, journey through the solar system, sometimes crossing paths with Earth. This understanding should not evoke fear, but rather a sense of wonder and duty. Wonder at the vastness and magnificence of the universe we call home, and a duty to protect the precious life that flourishes on our planet. The year 2004 marked a pivotal moment in our understanding of asteroid threats. The discovery of Apophis, an asteroid larger than the Eiffel Tower, ignited significant concern within the scientific community and drew global attention. Early calculations indicated a disturbingly high chance of impact in 2029, serving as a profound wake-up call. The potential for a major asteroid impact, once considered the stuff of science fiction, suddenly became a real and pressing threat, highlighting our planet's vulnerability in the vastness of space. Yet, Apophis turned out to be more of a cosmic educator than a bringer of destruction. Its close approaches, initially alarming, have offered priceless opportunities for scientific study. Each flyby helps us refine our knowledge of its orbit, analyze its composition, and enhance our planetary defense techniques. The revelation of Apophis and the vigilant tracking of near-Earth objects have ushered in a new age of cosmic vigilance and proactive measures. Moving beyond mere observation, scientists and engineers are now pioneering and testing methods to deflect or disrupt potentially dangerous asteroids, changing their trajectories to prevent disastrous impacts on Earth. Techniques such as kinetic impactors and gravity tractors, though still in their nascent stages, showcase humanity's creativity and resolve to safeguard our planet. Planetary defense is a worldwide mission, crossing national boundaries and bringing together scientists, engineers, and policymakers with a unified purpose to protect the future of humanity. This endeavor highlights our species' ability for forward thinking and our recognition that humanity's survival hinges on addressing both terrestrial challenges. In the ongoing cosmic dance between Earth and asteroids, knowledge is our most powerful tool. The more we learn about these celestial objects, their orbits, compositions, and potential threats, the better equipped we are to predict and mitigate any risks they may pose. Continued research, both from ground-based telescopes and space-based observatories, is essential for expanding our catalogue of near-Earth objects, refining their orbits, and identifying any potential hazards. International collaboration is also crucial. By sharing data, coordinating observations, and developing joint missions, we can enhance our collective understanding of asteroid threats and develop a coordinated global response. The pursuit of planetary defense is a testament to the power of human collaboration, a reminder that we can achieve extraordinary things when we work together towards a common goal. Innovative technologies and simulation models are being developed to better understand and potentially deflect hazardous asteroids. These efforts highlight the importance of global unity. As we embark on a new chapter of space exploration and technological innovation, the mission of planetary defense marks a pivotal point in our history. It showcases our creativity, our strength, and our relentless drive to protect our planet and ensure the continuity of life for future generations. The obstacles we encounter, both on Earth and in the vastness of space, require us to adopt a cosmic viewpoint, acknowledging our connection to the universe and our duty to safeguard this fragile blue sphere we call home. Let us aim to be wise guardians of our planet, not just for ourselves, but for all those who will come after us. Let us create a future where humanity, equipped with knowledge and fueled by a spirit of unity, can confidently traverse the cosmic seas, shielding our world from any celestial threats that may arise. This is our cosmic legacy, a legacy deserving of our greatest efforts and our loftiest dreams.